In our previous class, we discussed about inorganic compounds of carbon. Now we are going to discuss about organic compounds. The important organic compound of carbon is hydrocarbon. Hydrocarbons are compounds which contain only carbon and hydrogen. Which contains only carbon and hydrogen. We discussed about allotrope. Allotrope contains only carbon. Hydrocarbon contains only carbon and hydrogen. The main source of hydrocarbon is petroleum. Hydrocarbons can be divided into various classes. First, we can classify aliphatic or open chain compounds and cyclic or closed chain compounds. Open chain compounds can again classified into saturated compounds and unsaturated carbon compounds. Unsaturated carbon compounds again classified into double bonded compounds and triple bonded compounds, alkenes and alkynes. So we can classify unsaturated compounds again double bonded compound, that means alkenes, and triple bonded compounds, alkynes. Again, cyclic or closed chain compounds can be again classified into alicyclic compounds and aromatic compounds. So we can classify carbon compounds into many different classes. Most of them we can study detail in this chapter. First one, aliphatic hydrocarbons. Aliphatic is a word derived from alifer, meaning fat. Alifer is a Greek word. So, aliphatic hydrocarbons are derived from fats and oils. That is why it is known as aliphatic hydrocarbons. Aliphatic means fat. Hydrocarbons can be acyclic compounds, which are straight chain compounds, or cyclic compounds, the ring of carbon compounds. You can see the ring compounds. Aromatic hydrocarbons. Aroma is a Greek word meaning fragrance, that means smell, characteristic smell. Benzene and its derivatives include aromatic hydrocarbons. We use moth repellents tablets. You can see in bathrooms or wash basins a white colored tablet used for repelling moths, cockroach, etc. It is made from benzene. It has a smell. So, the compounds containing a smell is known as aromatic hydrocarbon. Then, aliphatic hydrocarbon again classified into saturated hydrocarbons and unsaturated hydrocarbons. In saturated hydrocarbons, carbon-carbon link should be single bond. Each carbon linked to other carbon by a single bond. In unsaturated hydrocarbons, carbon-carbon bonds may be double or triple bond or double bond. We studied about this in our previous chapter, bonding, chemical bonding, chapter 7. There are two types of bonds, ionic bond and covalent bonds. In covalent bond, there is three different types bonds: single bond, double bond, and triple bond. In carbon compounds, carbon-carbon may be in single bond, double bond, and triple bond. If the carbon-carbon bond is single bond, it is saturated compound. That means it is completed. Saturated means completed. If the carbon bond is double bond or triple bond, it is unsaturated. Unsaturated means not completed. If we can break this double bond or triple bond, we can add more carbon or other atoms. That is why it is known as unsaturated carbon compounds. Saturated hydrocarbons, that means alkanes. Methane, CH4, is the simplest alkane, which forms by linking bonding 4 hydrogen atoms to a carbon compounds in a tetrahedral fashion. We can simply draw it like this. A carbon share its 4 valence electron with 4 other hydrogen atoms. Okay, this is we can see here. This is methane. Methane contains only carbon and hydrogen. That means it's an hydrocarbon. Okay. If we remove one hydrogen from this and add one carbon, and it is again linked to 3 other hydrogen. That means C2H6. It's another compound. It's also a saturated carbon compound. Saturated carbon compounds are known as alkanes. If it contains only one carbon atom, it is methane. If it contains 2 carbon atom, it is ethane. The structure of ethane is shown here. The structure is like this. We can simply draw like this. If we add carbon, we can add hydrogen also. We get many compounds. Compounds containing 3 carbon atoms, 6 carbon atom, 8 carbon atom, 10 carbon atom, etc. etc. We studied the property of carbon, catenation. It can link many more carbon atoms to form a large chain. So there is a lot of alkanes. Alkanes means carbon compounds which contains only single bond. It starts from a single carbon atom with 4 hydrogen atom, methane. And next one is ethane, propane, butane. It's go like that. Increasing carbon atoms with a single bond to other carbon atom. We can make many other compounds. The general formula for alkane is CnH2n plus 2, where N is the number of carbon atoms in the alkane molecule. We can see the list of first 10 compounds, carbon compounds. First one is methane. Second one is ethane. We can just take ethane for studying CnH2n plus 2. For ethane, the chemical formula is C2H6. We have the equation CnH2n plus 2. We have the equation CnH2n plus 2. For ethane, N is equal to 2. So we can write like this: C2H2 into 2. N is equal to 2 plus 2. So we get C2, 2 into 2, 4 plus 2, 6. C2H6. That is a compound ethane. If we take another one, butane, we can take butane, C4H10. C4H10. So N is equal to 4. C4 CnH2 into 4 plus 2 is equal to C4. 2 into 4 is equal to into 8 plus 2, 10. C4H10. The compound is C4H10 is known as butane. Similarly, we get every compound by adding to this equation. CnH2n plus 2 is alkanes. Here we get first 10 alkanes. Alkanes are colorless and odorless compounds. Odorless means they have no smell. They have very low reactivity because it is saturated compound. In the previous table, we can see the difference between CH4 and C2H6 is CH2. By increasing, here we can see CH4 and C2H6. Difference is CH4 minus C2H6 is equal to C. CH4 to H6 is CH2. If we take another one, C4H10 and C5H12, the difference is same. C4 changes to C5. That means increasing one C. H8 to H10, increasing H2. That means CH2. The difference between is CH2 units. The series of compounds which is known as homologous series. Homologous series. The series which is differ by a single unit, CH2. Each homologous series has a general formula. The general formula of alkane is CnH2n plus 2. So general formula for alkanes. Then we are going to our next topic, isomerism in alkanes. What is isomerism? What's isomers? Isomers are compounds which have the same molecular formula but have different structure. The structure of compound is different, but the chemical formula is same. That compound is known as alkane, isomers. Many compounds shows different isomerisms. The first three hydrocarbons have no isomers because methane contain only one carbon atom, ethane contain only two, propane contain only three. There is no way to show change their structures. But if we going to another compounds, the compounds containing more carbon atoms, it shows different arrangements. Here we can see a straight chain arrangement of butane. It contains 4 carbon atoms. We can arrange in a straight chain. Here we change the structure. It's a branched chain arrangement. Clear? Butane, the normal butane is like this: CH3, CH2, CH2, CH3. The isobutane is like this: CH3, one CH3 is branched. Okay, and also its formula is slightly changes. If we get the butane, we get only C4H10. Okay, C4H10 is the chemical formula of butane and isobutane, but the structure is different. This is isomers in alkane. Similarly, we can see isomers in alkene, alkynes, etc. etc. The number of carbon atom increases, the structural isomers also increases. If a carbon compound contains 10 carbon atoms, it can form many different types structures by arranging its carbon atom linked to just the different types of branches. In our next class, we are going to study how we give names for each carbon compounds. We call carbon compounds containing 4 carbon atoms butane. Why? One carbon atom is methane. Why? Etc. etc. We are going to study in our next class.